Yeah, hi EmberFest, hi Madrid, glad to be here. So my talk is about advanced patterns for V2 add-ons. So yeah, my name is Simon, I work at CrowdStrike in a UI framework team. We are basically supporting all the product teams with like the framework, internal tooling, and the design system, and so on. Also part of the recently created Embroider core team. And yeah, feel free to get in touch on social media. I wasn't very creative with my internet handle, so it's just my name. Okay, before we actually go into like some common patterns for common problems, let's first give you a really short introduction into V2 add-ons in case you haven't really worked much with them yet. Thank you, okay. But before we do that, let's look what are V1 add-ons even. So V1 add-ons, as they exist since EmberCLI, are basically plugins specific to EmberCLI. They integrate with its Broccoli-based build system. And like you might think of add-ons like the packages that provide runtime code, like components that run in a browser. But actually, like their main entry point is Node.js based. So they're Node.js plugins and that emit the runtime code during the app's build, actually. So even that's basically the index.js file, and even if that's empty, it just means the add-on will just inherit all the default behavior of what a V1 add-on does. It does not mean it does nothing. And that has the problem that basically the more add-ons you have, the more inefficiency add up because each and every add-on integrates with your app's build. And yeah, that's something that V2 add-ons are trying to solve. So in contrast to V1 add-ons, they're basically just very simple static NPM packages. They're based on like ES module-based code. And the only way to actually like consume whatever the add-on provides is by importing their modules. There's absolutely no build integration whatsoever with V2 add-ons. On top of being NPM packages, they had a little bit of like Ember-specific features, like they can ship handlebars templates, which are not JavaScript, of course. They have this concept of app re-exports. I'm glad that Ed actually went into detail into this concept because that's kind of the thing. The app folder in V1 add-ons is basically the same thing where the add-on is kind of forcing the app to import something within the app's namespace so that kind of name-based lookup of components actually works. So V2 add-ons have this as some kind of like legacy feature support, which you already know from V1 add-ons. And they also have like a way to push public assets into the output of the build, very similar to the public folder that you have in V1 add-ons. But other than that, basically you can think of them as really just being pure NPM packages like Lodash or whatever. And they work both in classic and Embroider builds. So as Ed said, like Ember auto import is basically the polyfill that makes V2 add-ons work even in classic builds. Now you wonder maybe I don't have a build for them, and that's right, but you might actually want one for your like authoring experience, for convenience, for dealing with templates, with TypeScript and other things. But the important thing to understand here that this is different from the app's build. So the build happens basically before you publish the NPM package or use it within the app. It's not related to the app's build. So whenever you have like run the build and you have the dist folder typically in a V2 add-on and you publish that, as soon as you consume that add-on, it's fully static and does not integrate with the app's build. Okay, many new things to figure out and to learn. Don't be afraid, we have a V2 blueprint. Basically, it kind of distills all the best practices we think of V2 add-ons. So it has a monorepo setup for the add-on and the test app. Again, like we still currently need a full-fledged test app. to work. It's basically the dummy app that you know from V1 addons, which is kind of a weird concept. And so we have integrated that into a monorepo setup. And we do have a rollup-based build, as I said, just for convenience, so you can use all the latest tools like template tag, TypeScript, Glint, what else. But all of this is purely conventional. Like nobody is forcing you to use this. It just to make your life as a developer a bit easier. So, many new things. What's the one thing that I really should know about V2 addons? And I would say, give you maybe the recommendation to basically try to unlearn what you know from V1 addons. Like, don't try to match existing concepts you know from V1 addons and try to find the same thing in V2 addons. They're different, and you have to basically change your mindset a bit how you think of them. And maybe there's actually two things you should know. And the other thing is that you should understand the difference between a pull-based and a push-based approach here. So V1 addons are basically push-based, which means all the code that you have in your add-on folder, it gets pushed into the app's output, whether you use it or not. It just, by its sheer existence, the code of that add-on is part of the app. That's different with V2 add-ons because they use a pull-based approach, which means by default nothing gets used from a V2 add-on, and only the things that you actively pull into your app by means of importing it are actually getting to be used from a V2 add-on. Okay, now let's look into some advanced patterns, basically trying to show you some common problems and how you can deal with them in V2 add-ons, as the things are a bit different than what you might know from V1 add-ons. So the first thing I want to talk about is how you can import CSS. So let's say your add-on is providing some components that need some styling, and the problem here is how do I actually ship that CSS to the app? Because in V1 add-ons there is the styles folder, but that is push-based. Basically, all of that, what is in there in V1 add-ons, gets concatenated to the vendor CSS file, but that's not available anymore with V2 add-ons. So how can we do that? And again, in a pull-based world, the solution is to import the things. And in this case, we can import our own CSS. So, give you an example. So this is just a simple button here. Again, it uses a template tag syntax just because it's nice, but it would work the same way with a more classic style component. On the right, you see like a simple example of some CSS that your button might need. And on the left, you have that button and a template, and we see there is an import of our co-located button CSS. Now you might wonder, like, what? I'm importing CSS. I know I can import JavaScript, but what does importing CSS actually mean? And so this is explicitly supported in the V2 add-on spec. You can import CSS, and the semantics of that is basically that whenever the module that does this import is loaded, it is guaranteed that all the CSS that it imports is applied to the DOM. So when your component is about to get rendered, we know the CSS is already in DOM, and you would see it properly styled. The recommendation I would have is basically to import just the CSS that you need in the place where you need it. So a common thing is basically have your CSS co-located for the component, similar to like existing techniques like CSS modules or Ember component CSS. It has the nice benefit also that it enables code splitting and lazy loading of the CSS. So let's say your app is doing like a route-based code splitting under Embroider, and some components get only lazily loaded because they're part of another route. With that approach, also the CSS will get lazily loaded. Okay, another pattern I have here is about like static assets, which is kind of similar to CSS, but I'm talking more about like things like images, SVGs, and the like. So the problem is, how can we again make these assets available to the app's build? How will they get a public URL, and how can we refer to those assets? Because like in the case of images, you would actually have to refer to them and not have just a side effect only import. And again, the solution is to import them. So this example here, that's obviously a component every app needs. It's rendering our Tomster. And you see basically the template is just an image tag, and the source refers to that Tomster value. And where does that value come from? It comes from the import of just that image. And the semantics here is basically that when you import an asset like an image, it will give you the public URL of that image. So that's why you can just basically provide it to the source attribute, and it will make the image get rendered. There is some caveats here, so this is like not as well supported as with CSS, because it won't work out of the box yet. You would basically have to need your app users to add some configuration to some webpack configuration, either when you use Embroider or Embroider. But it's not terrible, as you can see on the right. It's basically a rule that says whenever you import something with one of those file extensions, use the asset loader that's built into Webpack. And that loader basically does what I just explained, like it will turn an import of that asset into the public URL that you can use in your app. There's also an RFC out, but not yet merged, which kind of will try to standardize this a bit more. And so that's why I'm saying it's not quite stable, what I'm showing you here. So the exact syntax of how you import an asset might eventually change, but the approach will be the same. Basically, it means you import the asset and you get back the URL. And additionally, like with our opinionated rollup config, when you use the V2 add-on blueprint, you would also have a little bit of config to that rollup plugin to basically say not only copy all the CSS files into the output of the add-on, but also the image that you have in your add-ons repo and that you want to have like distributed as the npm package. Okay, I talked earlier about it. There is also this push-based approach to like providing static assets. I'm not going to go into details because I would prefer the first one. Yeah, in case you might wonder, there is basically an equivalent to the public folder also to do similar things here. I should have mentioned or forgotten about this. The nice thing about this approach to import your assets is also that it will give you fingerprinting basically of that asset within an Embroider build. So in a classic build, you had this add-on, you might have seen it before, Broccoli Asset Ref, which kind of applies fingerprinting to all the static assets and then changes all the reference to that kind of magically in the build. That does not work with Embroider anymore, but basically importing an asset with that asset loader is giving you the same functionality in a production build. It will give you like nice fingerprinted URLs, so you can have those assets getting cached in the browser, and whenever they change, they are guaranteed to be updated. Okay, now to something other. So I'm talking about lazy loading here. The situation is maybe you are importing a large dependency and that would like increase your bundle size a lot, and you won't actually want to not increase the initial load by having the dependencies. You would want to load it only when it's actually needed. So how can we do that? And the solution for that is to use a dynamic import. And you see basically kind of all the solutions require to import something. That's kind of the pattern among all these patterns here. But that's no coincidence here. So let's see in an example. So you have an app that statically imports an add-on, a component from your add-on. Those arrows with like a solid line should indicate a static import. And that add-on imports a large package from NPM. So the solution here would be to make this last import basically a dynamic one, in which case the package itself would get its own chunk that is only loaded when you're actually calling that dynamic import. And the initial load will not be affected from this package. So that's the thing, maybe you have seen that before and wondering actually, is it something new? And it is not. So that has worked for a long time, basically since Ember Auto Import enabled this feature. And that's not something specific to V2 add-ons. You can do this in V1 add-ons and apps. But there are even like more tricky examples, which I'm going to show you now. So let's look at a case where maybe your add-on is importing multiple packages, or maybe the same package but with different like subpaths. So you would need like different import calls. And maybe it has like its own code, which depends on that, which is also big. Like that's basically referring to this module here, but it might not be a single module. It might be like dozens of modules or so. All of that, what you also wouldn't want to ship during the initial load. So if you apply the same pattern here, it would basically make those imports to those packages dynamic ones. Probably the bundler will end up with like putting each of those packages into a separate chunk, which is better than nothing, but not quite what we want. Also, there's a problem here that basically when you turn static imports into dynamic imports, it makes things more complicated, right? In that module here, because suddenly you have to deal kind of with state, like is that thing already loaded or not? And yeah, it just complicates things, and like static imports are just way easier to reason about. So what can we do here? And the solution is basically to think of the optimal boundary where you place that dynamic call, that dynamic import call, so which is the place where you're splitting like the initial bundle of the app with the lazy loaded part. And in this case, it would just make sense to kind of move that boundary a bit upstream, or in this diagram to the left. So that's what we do here. Now you see that our component basically does the dynamic import of a module that is owned by the add-on. And you see now the imports of the packages can be static again, which again makes things in the module easier. And the whole thing basically becomes a single chunk that gets lazy loaded. The add-ons code plus the code from those packages. And that's basically a thing that is new to V2 add-ons. V1 add-ons couldn't do this. Why is that the case? Again, think of pull versus push. In the push-based world, all the code of the add-on is already part of the app. It is eagerly loaded, and it wouldn't even make sense to try to dynamically load the code because it's already there. And V2 add-ons, for V2 add-ons, it's different. Like as long as you don't, you only import a certain module with a dynamic import and not have any static imports, it will like be able to lazy load its own code. So this is nice. Let's look at an example here real quick. Like this is just a component that renders some 3D scene using assumingly 3JS, which is pretty large dependencies, so you would want to lazy load that. So you see we render a canvas and we call a setup canvas modifier here. Like the details of 3JS are not like important here. The important part is basically this dynamic import, where you see it's actually importing from its own add-on namespace. And when that is resolved, it's calling the function and passing the canvas, which will then render all the things. So that's nice to be able to do that. There are different examples even about lazy loading. Let's say maybe your actual component needs to has a large chunk of code that you want to lazy load, or needs to directly like interact with that large dependency. And you just think of like a getter, which is supposed to return something like a class that you import from that dependency. So you cannot easily use that without making all the usages also into dynamic imports. Oops. So, and that's not so easy to do. So how can we do? How can we lazy load the code in this case? And the solution is again, of course, an import and a dynamic import. But we can actually dynamically import the component itself. So again, let's look at something like this. Like we have like a more complicated module graph here, where the component depends on a package and depends on other modules and whatnot. And so what we can do here, basically again, the solution is try to figure out what is the optimal boundary to introduce that async loading. And in this case, it could make sense to basically to find a place where you have the least amount of friction by introducing that asynchrony. And I would say here you could basically put the import, the dynamic import, between the app and the component. So in this case, the whole thing now becomes a separate chunk, the component itself, with all the modules and packages that it uses. I'm going to show you a code example real short, but it can even get more involving. The problem here is that we are basically delegating the work to deal with that asynchrony to the app. And let's say maybe the app wants to render our fancy component in many places, which means, hey, you would have to like dynamically import it everywhere and wait for the import to be finished to then render it. And that might become annoying, and you would want to not have to deal with that complexity everywhere. And there's a solution I would suggest here to basically provide a wrapper component that abstracts all this lazy loading away for you. Again, this is like the module graph that we had. And we can introduce that wrapper component here. And you see basically that now the app does not do the dynamic import anymore. It just statically imports that wrapper component. And the wrapper component now does the dynamic import. And so in this case, you know, the app doesn't have to deal with this. And yet still, it looks like from the app standpoint that everything is like static, but actually there will be a delay for loading the chunk, and then everything will work again, but the app doesn't have to care about this. There is one caveat here, though, with like lazy loading components, and that relates a lot to what also Ed mentioned before in the talk, this concept of like looking up a component by its name, going through the container and the resolver and so on. So as I said earlier, V2 add-ons have this configuration option of defining app re-exports, which is again the equivalent of the app folder in a V1 add-on. And these app re-exports basically force the app to statically import some code, so it's available for that lookup-based mechanism. And again, if you already have imported something statically, it doesn't make sense to even try to load it dynamically anymore, because it's already eagerly loaded then. So the thing you have to be aware of that whatever you want to lazy load, like a component, in this case, this one, it must not be in the app re-exports. You know, you just have to explicitly import it It does not implicitly get statically imported through that app re-export. So that applies to this example, but also the previous one. So just make sure if you use this pattern and that you have covered this. Let's look at an example how this could work. So again, we have here our component that renders this 3.js scene. And you can actually see, if you compare this to the previous example, that is gotten like simpler. The modifier, it was like, I don't know, 5 lines before, it's just not 1 line. That's just due to what I mentioned before, that with the static import, things get easier. You don't have to deal with promises. And that's nice and easy to read in this case. And again, the complexity of lazy loading happens in that wrapper component. And that's an example for that. So we are basically, in this case, using an Ember resource here, and even a utility function from that library, which gives us some nice like async derived state, so we can render like loading and error states. And the important part, again, is here in the definition of that resource, where we await the import of our own code. But in this case, it's not just a JavaScript module, it's our component that we are lazily importing. And when that has resolved, we are returning default, which is the default export. So basically, whenever that import has resolved, the value of that resource is the component class that is exported from that module. And now, how can you render that actually? It's pretty easy. You see it in the else statement here. So basically, at this point, we know it has finished loading and there was no error. So the value of that resource is now our component class. And we can render it just by putting it into angle brackets. This thing might look weird if you look at this for the first time, like does not look like a typical component invocation. But it's actually the exact same thing that you have with any other template tag usage, where you're not going through this name-based lookup by, you have the name of the component, you look up, it gets looked up in the container if it's already there, if not, just the things that Ed showed you in the talk before. But we are rendering it, we're using here is basically as a value. So if you import something, a component, and render it in template tag, you render it by the value, because the import is just, the value of that import is just that component class. And in this case, it's just, the value of that resource, but it's nothing else. So that perfectly works fine. Okay, different topic now. So that's something I kind of discovered in one of the add-ons that I've been working on. It's called Ember Responsive Image. I'm just taking this as a simplified example to describe the problem here. So we have basically learned already that V2 add-ons are static, so they don't integrate with the build. But what if actually your specific use case requires something like that? Like it needs to process some files maybe, and the files are owned by the app and not the add-on. So the add-on cannot process them up front. It has to be part of the app's build. And the solution for that is basically not to revert to kind of the old broccoli-based world and integrating with Ember CLI, but instead you can ship a build plugin for whatever the final stage, the bundler of your Ember app uses. And in this case, it will exclusively be webpack, because that's used both by Ember Autoport and Embroider. But it could be like with Vite, you would have to ship a different plugin or a unified one. Okay, so let's look at this example. So you can provide a build plugin, as I said, alongside the actual add-on that features your runtime code. I would probably suggest that you ship it as a separate package, so dependencies are more isolated. And what you cannot do really is to make it magically work as you know it from EmberCLI. But it's not bad. So basically, you would have to tell users how to add a little bit of config to make this work. And that's basically another rule here that you would have to add to your webpack config, which says whenever you import an image, process it with the loader that is provided by this package here in this example. And this looks very similar to the previous pattern that I showed you about importing static assets. It's basically the same thing here. And this would allow you here in this example about images to let your users import images. And as you can see here, actually they get processed and you can pass parameters to them. That's also something that's nice about this approach, because with an EmberCLI-based approach, you would probably have to use some global config to configure what the EmberCLI broccoli-based thing does. In this case, you can define things or configure things wherever you use it. So I can say here, I want to render the Tomster image, but with a width of 300 pixels. Let's look at such a loader. I'm not going to get really into details. I just want to show you the concept of what a webpack loader is and how it's supposed to work. So a webpack loader is basically a function that receives an input, which is basically the content of whatever you are importing. It could be a string or a buffer in the case of binary files, as in this case here. And whatever you do in that loader, the important part is when you return from the function, it has to be a string, and that string has to be a valid JavaScript module, because that's essentially what we can import, JavaScript, right? And similar to the assets pattern, this loader will basically turn whatever you want to import, which is not JavaScript, into something which is JavaScript. So it's the semantics of that import are clear at that point. It's just JavaScript module. So in this case, we are basically getting that query param out of the import path here. We're using Sharp as an image processing library to resize the image with that given width, turn it back into the buffer, generate a file name for it, which also includes this hash. As I said, this makes this is basically the fingerprinting approach under webpack. And then we emit this file. Emitting means basically making this file be part of the final output of the build. So we emit the file under that file name with that image data that we have done here. And again, the interesting part is the return. So what are we actually returning here? And it turns out this is like a webpack specific thing, and we're returning the file name with that. So basically, we are returning a string that is the public URL of that processed image that we have handled in this loader, which again is very similar to the previous pattern of importing just static assets. We get the URL back. It's just that we're not copying the file as is, but processing it in some way. And again, this was just an example about images because I had to deal with this case, but whatever else you might want to do, if there's something you want your users to import, which is not JavaScript, and you need to have something that makes this import work, providing a package with a loader that turns that import of something into actually JavaScript, so your runtime code can actually deal with it. Okay, final pattern I have for you, and there's a reason I put this at the end of the list because it's kind of a catch-all solution. Whenever the more the patterns that deal with static code don't work, Embroider macros, which is a package from a Embroider related package, might be a solution for that. So when do you use that? You use it when your code basically needs to show some different behavior based on the app or its context or its dependencies. And the problem is we learned that V2 addons are static, so how can we change our code based on some information within the app that we don't know when we actually publish the code? And the solution here is Embroider macros again, which do this kind of code transformation, but at the app's build time, basically. So they're kind of AST transforms that can transform your JavaScript or your template code at the build time of the app. So some common use cases are there's a dependency satisfies macro, which lets you do different things based on the existence of dependencies or the version of it. So let's say your add-on wants to do one thing when your app runs with Ember 5, and a different thing when your app runs with Ember or another version like Ember 4. There's also macros for dynamic configuration, which allows you to actually make your add-on configurable. So you could like make your users pass a flag to it, and then again you have conditional code that makes your add-on do the one thing when that flag is enabled, and another thing when it is not. The good thing about these conditionals is that Embroider macros will actually like eliminate the dead code of this. Basically, if you have an if then else, then either the then or the else is going to be executed, and the other part will be stripped away. So you're not shipping like unused code to your users. And there's another macro which is called import sync, which is kind of a mix between the static imports that we talked about and the dynamic imports, because it's synchronous, so you don't have to deal with promises, but also allows to dynamic usage. Like you could put it in a then statement of an if clause, which you cannot do with a static import. It has to be at the module head. And you can use it for things like conditional imports, like when the dependency is there, I import it with import sync, otherwise I do something else. So this might cover a few of like the edge cases that you might run into, but we all know the famous sentence like, with great power comes great responsibility, and I would urge you really to not reach into this until this is really the only thing to make your use case work. So whenever like a more static approach works, use that. But there are like edge cases where you actually need to have some of these abilities here to make your add-on code work. And that's almost all I have. I just want to give you a few more links. Like everything went pretty fast, I think, in this talk, and there were a lot of code examples. I have pushed all the themes to that repo, so when you want to actually check them out and see them running, check out the repo. Then we have the blueprint, which is basically the place where a lot of the V2 add-on development and changes happens. So go check that out. File issues if you see some problems or you want some features. Also kind of part of this effort for this talk was to work on some FAQs for how to author common problems for V2 add-ons. So they're not online yet, but I hope we will have some more better documentation how to work with V2 add-ons in the future. And of course, Dev Embroider on Discord is the go-to address if you have questions or need help from someone from the community. And yeah, that's all I have. Thank you.